Have you ever wondered what AI or artificial intelligence really is? It's a term that's been on everyone's lips for a while now, often hailed as the future of technology. But what does it mean? In its broadest sense, artificial intelligence is a branch of computer science that aims to create intelligent machines. But what does intelligent mean in this context? Well, it's all about mimicking or simulating human intelligence. We're talking about machines that can learn, reason, problem solve, perceive, and use language in ways similar to humans. Whether it's Siri understanding your voice command, or a self-driving car navigating through traffic, AI is behind it all. It's about creating systems that understand, think, learn, and behave like humans. But this is just the tip of the iceberg. Now, after knowing what AI is, let's dive into its fascinating history. It all started way back with influential figures like Alan Turing. A British mathematician and logician, Turing was a trailblazer in the realm of computation and artificial intelligence. His work during the mid-20th century, particularly the Turing machine, set the stage for the digital age. Turing wasn't alone in his pursuit. Other prominent figures like John McCarthy and Marvin Minsky also made significant strides. They delved into symbolic reasoning and problem solving, exploring the idea of machines that could mimic human intelligence. This era of exploration and discovery also saw the birth of various AI projects. For instance, the logic theorist dubbed as the first artificial intelligence program was developed by Newell and Simon in the mid-50s. It was capable of proving mathematical theorems, illustrating the potential of AI. These pioneers laid the groundwork for what would become a groundbreaking field of study. Their early efforts sparked a revolution that continues to shape our world today, setting the stage for the fascinating journey of artificial intelligence. The birth of AI as a formal field took place at the Dartmouth Conference in 1956. This historic event gathered some of the brightest minds of the time, including John McCarthy, Marvin Minsky, Nathaniel Rochester, and Claude Shannon. At this conference, they proposed that every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. The Dartmouth Conference set forth a series of ambitious goals, aiming to explore topics such as natural language processing, problem solving, learning and perception, and even creativity. This gathering sparked a wave of optimism and excitement, fueling the belief that machines could one day mimic human intelligence. The contributions of the Dartmouth Conference to the field of artificial intelligence can't be overstated. It was here that the term artificial intelligence was coined, and it's here that the foundation for modern AI was laid. This conference was a turning point, marking the beginning of AI as we know it. In the early years, AI was all about logic and rules. This era was dominated by symbolic AI, a method that used symbols to represent real-world entities and used logic to solve problems. It was like teaching a machine to understand a language of symbols and then using that language to solve problems. Now let's talk about expert systems, a shining star of this era. An expert system is a computer program that uses AI technologies to simulate the judgment and behavior of a human or an organization with expert knowledge and experience in a particular field. It could diagnose a disease, predict the weather, or even play chess like a grandmaster. These systems were built on vast databases of expert knowledge, and they became quite popular in the 70s and 80s, finding applications across various industries from healthcare to finance. These systems were a leap forward, but they also had their limitations. They were as good as the information fed into them, and they struggled with tasks that required common sense or understanding of context. The AI winter was a period of disappointment and disillusionment. The term, coined in the late 70s and early 80s, referred to a time when the initial hype and enthusiasm surrounding artificial intelligence began to wane. What led to this sudden chill? A combination of unrealized expectations and technical limitations. Despite promising beginnings, AI failed to deliver on its ambitious promises. The machines were not becoming as intelligent as anticipated, and the grand visions of the early pioneers seemed far from being realized. Furthermore, funding for AI research dwindled. Governments and investors, disenchanted by the lack of progress, withdrew their support. This financial drought led to a slowdown in research and development, further deepening the AI winter. Technical limitations also played their part. The technology of the time was simply not advanced enough to handle the complexity of AI algorithms, but despite the setbacks, AI was far from finished. This winter was merely a pause, a time for AI to regroup and prepare for the resurgence that was yet to come. The resurgence of AI came with the emergence of connectionism and neural networks. Now you might be wondering, what's so special about neural networks? Well, they're inspired by our own brains. Neural networks are computing systems vaguely modeled after the biological neural networks that constitute animal brains. Each neuron in a neural network takes in input, does a little computation, and then passes the output onto the next neuron. The real magic happens when these networks learn. Through a process called backpropagation, neural networks adjust their internal parameters and learn from their mistakes. This means they can improve their performance as they process more data. This self-learning ability was revolutionary. It meant that instead of programming a computer to complete specific tasks, we could now train a computer to learn how to complete tasks by itself. This sparked renewed interest in AI, as people began to imagine the vast range of possibilities this technology could unlock. This marked the beginning of a new era in AI. Machine learning and data-driven approaches revolutionized AI. Just as a butterfly emerges from a chrysalis, so too did AI evolve with the advent of machine learning. Instead of manually programming rules and logic, machine learning algorithms allowed computers to learn from data, much like how humans learn from experience. This shift in approach was akin to a seismic tremor in the AI landscape. Decision trees, support vector machines, and later deep learning algorithms became the new tools of the trade. These algorithms didn't just crunch numbers. They extracted patterns, made predictions, and even made decisions. And it wasn't just about the algorithms. The rise of big data meant that these machine learning models had an ever-growing playground to learn from. From recognizing faces in images to understanding and generating human language, these data-driven approaches unlocked a new realm of possibilities. These approaches opened up a world of possibilities, from computer vision to natural language processing. Today, AI is everywhere, from autonomous vehicles to virtual assistants. Its fingerprints are all over the 21st century, revolutionizing industries and redefining possibilities. Advancements in artificial intelligence have skyrocketed, spurred by exponential increases in computing power, the pervasiveness of cloud computing, and the availability of big data. Autonomous vehicles leverage AI to navigate bustling city streets, while virtual assistants utilize natural language processing to comprehend and respond to our commands. AI is even transforming healthcare, with machine learning algorithms predicting disease outcomes and aiding in drug discovery. These advancements aren't just confined to laboratories or tech firms. They're embedded in our daily lives, in the recommendations we receive from streaming services, the smart home devices we interact with, and the personalized ads we encounter online. The rise of AI in the 21st century is a testament to human ingenuity, a celebration of our ability to create machines that learn, adapt, and evolve. With big data, cloud computing, and improved computing power, the future of AI looks promising. As AI continues to evolve, so do the ethical considerations surrounding it. One of the key concerns is the potential for biases in AI algorithms. These biases, often a reflection of our own societal prejudices, can lead to unfair outcomes in areas such as hiring, lending, and law enforcement. Equally concerning is the issue of privacy. As AI systems become more sophisticated, they're able to collect and analyze vast amounts of personal data. This raises questions about who has access to this information and how it's being used. Then, there's the impact of AI on society, particularly in terms of employment. While AI can streamline processes and increase efficiency, it also has the potential to automate jobs, leaving many people out of work. These are complex challenges that require thoughtful and proactive solutions. It's crucial to address these issues to ensure AI benefits everyone. So, what does the future hold for AI? It's a question that both excites and perplexes us. As we stand on the precipice of technological advancement, the possibilities seem endless. We're seeing the rise of explainable AI, which aims to make the decision-making processes of machines more transparent and understandable. This is a crucial step in building trust between humans and AI, and in ensuring ethical standards are maintained. Moreover, AI safety is becoming a significant field of study. It's about designing AI systems that act in the best interest of humanity, even in the face of complex, unpredictable situations. And then there's the holy grail of AI research, the quest for artificial general intelligence, or AGI. This represents AI with the capability to understand, learn, and apply knowledge across a wide range of tasks, just like a human would. As we look to the future, one thing is clear: the story of AI is far from over.